7.2 finding critical value. We have already have an idea about what is critical value and critical region. Again, just I revise you that when we are doing hypothesis testing, we have to select a region uh, to reject the hypothesis, null hypothesis. So sometime it is in a number line, it is from the top area, right? So this is one tail. Sometime it is from the number line, it is from the lower area. This is upper area, lower area. Sometime it is from both side. Uh, Usually they will give in a 5% threshold or 2% threshold or 6%, 10% threshold. So those are the probabilities. So it means this total area is up to, if we consider 5%, 5% or 0.05, the addition of total area. And critical value is the point. So this is the cutoff point. So this is the cutoff point. Now, another thing, when we discuss if it is given 5%, then for so one tail it is 5, but if it is two tail, this 5 we have to divide by 2, that is 2.5. Then we have to apply 2.5 and 2.5 uh, equally. Now, regarding this cutoff point or the cutoff value, um, if it is a discrete distribution, uh, we work with the previous example 19, that 18, 16, 15, 14, 13 likewise, uh, uh, 20. I will take this is 14, 13 and 12, something like that. When we consider for discrete distribution, what are the discrete distribution? The binomial or Poisson or geometric. Why it is discrete? Because it will take only 13, 14, they don't take decimals. Now when you toss a coin, this x value can be 1 or 2 or 3. It can't be 2.2 or 2.3. So because of that reason, when we measure 5%, assume that we measure 5%, the cutoff point is here. But we can't take the cutoff point. So the 5%, the 0.5 probability is bringing to somewhere here in between 12 and 13. 13 is too low, 13 is low, 12 is more than 5. So usually cutoff point uh, lies in between. But since it is a discrete distribution, we have to select this one as a critical point, critical value. This is not the critical value. But in a continuous distribution, because the number line is continuous and there is no such a issue, the 5% value you can exactly take 5% value. Assume this is discrete distribution, then this value is the cutoff value is the critical value. So it is 12 point, let's say 5612. So we can take that is the value because this value is allowed by the variable because this variable is continuous. So normal distribution, then beta, alpha, gamma. Example for continuous variable is height or say weight, anything you can measure with the continuous scale. And important thing is here now, when we give the threshold, when they have the threshold with 5% or 10%, the given, the cutoff point is sometimes not the critical point, critical value. But in the continuous, yes, this point, this boundary is going to be the boundary point is the critical value. So because of this, the critical value is the first value to fall inside the critical region. Now we know this is the critical region. So the critical value, so according to this one, the boundary is here, 12 is more, 13 is less, and 13 is the critical value. So the critical value is the first value to fall inside the critical region. So 14 also a critical value. It's the second value. Now this is where you will get a actual critical value because actual significance level. So this significance level is 5%. So this is the boundary, but we can't take that one. So this is our boundary now. 5% we can't take. So this probability is less than 5%. This amount. So maybe let's say 4.03. This is 0.05. So this is let's say 4. So this may be 0.043. So this actual significance and the significance, there are two terms in this discrete distribution because of this issue. This green area up to 13 is the actual significance level. And given is the significance level. 5% is the given. This area also referring as another name, probability of rejecting or probability of incorrectly rejecting the null hypothesis. This term you can't understand. For the time being, just keep what is actual significance level, the probability of uh, incorrectly rejecting the null hypothesis. This is another name for this area because this is we need to talk type 1 and type 2 errors, which is beyond this A level, A's and A level here. If you do further statistics, yes. But for the time being, I'm not going to explain. If somebody asks what is actual significance level, you know what is the meaning of actual significance level. Because you can't take the given significance level 5% because 5% lies in the middle, but the variable is going 12 to 13 to 14. Because of that, actual critical value is this one, and up to the that probability is the actual significance level or actual probability. Or there's another name for it, probability of incorrectly reject null hypothesis. Just keep in your brain and then uh, keep in that this is equal to this, that's all. Try to explain this one now. It may confuse you because you don't have the relevant knowledge to understand this yet. And so critical value is the value to fall inside the critical region. The first value to fall inside the critical region, you can understand that one now. So assume that this is, I rewrite again, the given threshold is alpha, and the value is a, the critical value, uh, the reading is a. Assume that critical value, this is a. Then the probability of rejecting, we write probability of x greater than or equal to a less than alpha. Then this is the rejection region. So including this value, and this is the rejection region. So this is alpha. So this is a boundary for alpha. So this is boundary for alpha. This is boundary for alpha by 2 and alpha divided by 2, because this is two tail. When it is given alpha, you have to share it equally. So if it is lower tail, probability, so this is a, probability of x less than or equal to a has to be less than alpha. Now if I write here for this one, probability of x, I will take this value is a1 and a2, okay, b1 and b2, x value less than or equal to b1 has to be less than alpha by 2. And for this one, probability of x greater than or equal to b2, from here to here including that value, has to be less than alpha by 2. This is a probability. Now this is for uh, discrete, but there's a small change when you come to the continuous. So continuous one will, there you can't see that the equal sign here. So we'll discuss when it's come to the normal distribution. So this is for discrete distribution. What is the acceptance region? Now according to this sum, the given threshold is 5%. Unfortunately, we can't take that one. So then it has to be 0.04, which is 4.3%. Then eventually it will come up to here. Now this is going to be the acceptance region, and this is the critical region or rejection region. If I apply to here, so this is how we write the rejection region, probability of x greater than or equal to 13 less than 0.05. We still stay with 0.0505%, because we know that um, if any value go beyond that, it is going to be go more than 5%. So it means less than. If we take 12, yeah, definitely it is. Now what we are checking here is probability of, so this is the, according to this one I wrote the rejection region, probability of x less than uh, greater than or equal to 13. So that's in writing, this is how we show this one. And then, or if you want, you can drop this one, but it's better to, so when you write, okay, let me come back to here, probability of x greater than or equal to 13, 5%. So when I'll drop this one, then this is the probability of rejecting. And when I drop this one, this is the values for rejection area: 14, 15, 16, 17, likewise up to 20. By 20 because I took up to 20 trials. Now what is your test in here is you get x less than or equal to any x values has to be less than 5%. Then you are substituting here, okay, x equal 14, you put 14 here, and you put 14 here. Okay, you check uh, it is in the rejection region, yeah, then reject, yeah, less than 5% definitely. And 16, so instead of x you are putting 16, yes, reject. What will happen if you put 12? Is it less than? No, accept. What will happen if you put 8? So it is less than? No, accept. So basically you are testing on this one, probability of x less than or equal to x, less has to be 5%. So this x value can be any value. X is changing up to 0 to 1 to 20. So according to your experiment, when we toss 10 times, so then the number of getting head is 10, then you put 10 here, then you can count the probability. That probability is more than, because 10 is here, then it is, we are accepting the null hypothesis. If it is got 20, yes, it's definitely bias. This is, and it is less than 5%. This is the rejection region, but practically you are doing this one x. So you can stay with this one as well. Probability of x less than or equal to x. This has to be less than 5. You can write the rejection this way as well. Rather than, so this is more realistic, the second method. So if you can grab this one, so you can stay with that. So in here, then probability of x less than or equal to, you can take simple x, and here also simple x and simple x. Let's discuss example 3. A single observation is taken from the binomial distribution. So binomial distribution x, follow, I take x as a variable, 6, and p, h naught is given is p has to be 0.35, and h1 is given p has to be greater than 0.35. So we know that this is going to be a one upper tail test. Using 5% significance level, find the critical region for the test. So this is a 5% significance level. 0, 1, 2, 3, 4, 5, 6. So from the table, I jot down all the cumulative probability. So this is cumulative probability. So that's why when it's come to 6, it is 1. Now what is the probability of getting x equals 6? Because there's no point of writing less than or equal to 6 because, sorry, greater than or equal to 6 because there is only one 6, there is no 7. Because of that, this is x equal 6 is 1 minus probability of x less than or equal to 5. So this value is going to be 1 minus 0.9982, 0.9982, 0.00, that is 18. It means as a percentage, when you multiply by 100, this is going to be 0.18 percentage. So we need 5%. So probability of, let's go to x greater than or equal to 5 from here onwards. So I want to find this one plus this one. So simply I can get 1 minus cumulative. So probability of x, 1 minus probability of x less than or equal to 4. So 1 minus 4 is 0.0977. So this is 0.0223. That means 2.23 percentage as a percentage. And then probability of x less than or equal to 4. From we first check this one, then this one, then whole three together. 1 minus probability of x less than or equal to 3. 1 minus 0.8826, that is 0.1174 as a percentage. This is going to be 11.74. Now this is 2.23. So we need 5%. We need 5%. This is the area we need 5%. But when it's up to 4, up to 5, it is going to be how many percent? 2.23. And up to 4, it is here. That is going to be 11.74. We can't take 5 now. So then, as we discussed, the critical value is the first value to get into the region. So then we have to withdraw back to here. So the critical values is going to be 5 and 6. Critical value is going to be 5 and 6. Sorry, not the critical values, critical region. Critical region we can tell in terms of numbers 5 and 6, or as a probability. Probability of x less than or equal to 5. sorry, greater than or equal to 5. Or this is also better way of writing: probability of x greater than or equal to simple x less than 5%. This is a standard way of writing. But this is the standard. But if we need more specific, we have to give in terms of critical region is 5 and 6, or as a probability of x greater than or equal to 5. Or the can use this as a significance level as well. But for a discrete one, it is going to be actual. As a word come actual, but continuous, it's going to be the significance level. So question is asking, write the critical region for this test. So the critical region 5 and 6, and the other question is state the actual significance level for this test. So then the same question is asking express this area as a probability, what we wrote now. So part C, that is going to be probability of x uh, greater than or equal to 5, so which is 0.2, 0.0223 or 2.23. Example 4, random variable x follow binomial 48. So h naught is 0.25 and H1 alternative is P not equal to 0.25. It means it's going to be two-tailed. So this is the binomial follow 0.25, and they want to test in this one 2% significance level. It means so alpha is 2, and since it is 2, we have to take alpha by 2, alpha by 2. It means from both sides 2 divided by 2, 1% each. 1% each from the both side. So this is 0.01 and 0.01 from both sides. Now we'll find the distribution. Example 4. So we'll find that probability of x less than or equal to, so this is the cumulative table from the book, is given 0.0001 0, which is 0.11%. Probability of x less than or equal to 3, 0.0041, that is 0.4%. We need 1%. And probability of x less than or equal to 4 is going to be 0.0160. This is 1.6%. So this is lower, this is more than 1. This is less than 1%, and this is more than. So we can't get 1% exactly. So in that situation, we will go for this one, the lower one. Probability, so the critical region is x equal 1, 2, 3. So lower tail critical region is x value is 1, 2, 3, or you can write 1 greater than or equal to than 3. So I jot down the table values. 16, 17, 18, because when I look at the table, I can see that 1 minus this value is more similar around 1%. So let's first of all find in up to this area what is the probability. Probability of x greater than or equal to this area 18 is 1 minus probability of x less than or equal to 17, that is 1 minus 0.9953. So that value is going to be 0.00160 so which is 1.16. Now this is more than that, so this area is more, so we'll go up to here. We'll take up to 19, probability of x greater than or equal to 19 from here to here. 1 minus probability x less than or equal to 18, this is 1 minus 0.9983, so that value is 0.0017. It means 0.17 percentage as a percentage. 19 or less value is going to be 0.17, but if we jump to 18 or more, this is going to be 1.16, so we need 1%. Then the only possibility is we have to go back to 19. So the critical area going to be 90, 20 up to 40, 19. And the critical region is going to be now 19 x up to 40, and probability of x greater than or 90 is 0.0017. Now this is according to our existing knowledge, but we have to do a bit differently for the two-tailed test. So now I'm going to discuss how it's going to be adjust. Basically, this is according to our existing knowledge we found out, but there should be sometime it is depend on the sum. For the upper tail and lower tail, this value may be bit we will get differently. So we will see that theory now. I draw again this one. This is the lower boundary we discussed. This is the upper boundary. So 2%, it means we want to give 1% for both sides, 1 and 1. So usually 1 is here in from lower side, and this is from upper side to here. And now usually we will select the value. This is applicable to the two-tail test. From this distance, this is the 0.01, and now we need to see the difference from here to here and here to here, and we have to select the most close one to the 0.01, and here as well. So this is one way of balancing. So we'll work that. So what is from this difference? From here to here difference, we can find 0.100 0.0100 minus 0.0047. So this is going to be 0.0053, and then I'm going to find this distance. from this one minus this one, 0.0160 minus 0.0100. So what is this? Is going to be 0.0060. Now for this is fourth value, this is third value. Now the third value is much closer. So then we will take the boundary as critical region as 0, 1, 2, 3. And for the upper tail, when you look at, so this is from the boundary. When you look at, this is O and this is less. So usually we will take 19 and 19 to 40. But for the two-tail test, we have to look at the much closer one. So I'm going to find this distance, that is 0.01 minus 0.0017. So that distance is 0.0083, and then I am finding from 1 to this one, 0.0116 minus 0.0100. So that difference is 0.0. Now we can see this is much closer. This value is closer to 1. This is closer to 1. In here, this is closer to 1. So then we are taking 18 as well. So then this is the only way when we do two-tail test. We want to select the much closer value to the this one, the given significance level. Now, instead of 0.11, 0.01, we took from lower level 0.0047, and then from here, instead of 0.1, we took the most closer one again, that is 0.0116. So then the part C, the question is, what is, write down the actual significance level. So actual significant level is this one. It means as a percentage multiplied by 100, 1.63 instead of. Somehow this actual percentage has to be always less than or equal to 2%. If it is go beyond, it is an issue. Because if the third party is giving that we don't any error happen 2%, then we have to stay that one. We can't call no, we have made it to 2.1. There's another way of doing this one as well, which I can't see. This is for your knowledge. I'm explaining here. You may need this knowledge now. So this is, we are approaching much closer one. Now instead of that, now we have two options here. So 3, when you look at 3 is lower and 4 is more. For this one, 19 is lower, 18 is more. Then we are coupling like this. This less one with the highest one here. And the highest one with the less one. And we will add those two together. This is another way of adjusting this one, this two-tail test. And we'll add those two together. Now what is this one? 0.0047, and this extreme value 0.0116, and this is going to be 13. So we know that we had this one and the other one 0.0160, and this one. And addition of this one is 7710, like this, 0.0177. Now we have two options, 318 or 419. Now then we are looking which value is much closer to 0 point total, 0.02. So this value is closer to 0.02 because the addition, not this one. This is bit far, this is more closer. Then according to this selection, it's going to be critical region 0, 1, 2, 3 and come to 4, and then again 18. We drop 18 here because in the lexicon, so this is the one, and 19 to 40. Right. So if previously we discussed much closer one, then we stay with 0 to 0, 1, 2, 3, and then 0, 1, 2, 3, and 18 to 40. So here 4 is not here, 18 here, here 4 is. It is up to the company how they want. So they will specify we need like this. So then we have to do our calculation accordingly. For this exercise, we are not using any of this type. So we are stay with the closer ones, closer levels, closer one to this one.